Now, from there, these basic results, there's three kind of variations on the theme. And every trig, integral, and derivative is really just one of these kinds of, what's the word I'm looking for? When you've got a, in music, when you've got like a theme and it just, what's it called? What is it? Is it no, it's another word I'm looking for. Is it a movement? I don't know. It's the same kind of idea, and you just see it dressed up in different instruments and different tunes and tempos and that kind of thing. But it's still these three. So the first one is chain rule. Or, since we're thinking about integration, really it's reverse chain rule, right? Example. I'll do a simple one. The derivative of, say, sine 5x. What is it? It's chain rule, right? What is it? It's 5 cos 5x, isn't it? Because you differentiate the inside, which gives you 5, and then you differentiate the outside, which is sine, goes to cos. No problems, okay? So therefore, if I were to integrate 5 cos 5x, I would go back exactly where I came from, with the exception of the constant, okay? But, often you won't have that 5 out the front. You'll see this. What's the difference between these two lines? It's just that this line is 5 times smaller than this line, isn't it? So therefore, the right-hand side should be the same. Why don't I have to divide the constant by 5? Because it just will be another constant, exactly right. So it doesn't matter, it's still just C. Great. Now, there's chain rule. It comes up in some unusual places you wouldn't expect. For instance, if I asked you what the integral of tan was, you might think, why didn't it appear over here? It's kind of like one of these standard results, right? And the answer is, it's because it involves reverse chain rule. The question is, what? Now, I can't remember. I vaguely remember mentioning this before, okay? So let me try and help you a little bit by writing this tan as sine over cos. I'm pretty sure I did mention this, but I think it was a bit ahead of time, okay? Now have a look at this. I know that doesn't look like it's much more helpful than this, but it really is. It really is. Let me do one more thing. Slap a minus sign out the front. You're like, why would I do that? It's so that I can get a minus sign on the numerator. Now have a look at that. Believe it or not, this is a form that you're familiar with. You've worked with this before. This numerator and this denominator, they're not just random. I got that negative sign there for a reason. How are they related? This really, negative sign is the derivative of cos, isn't it? This is in the form, f dash on f. Okay? Now, this is, I really should have said reverse general. What function do you differentiate and you land on that when you use chain rule? And the answer is a log function, right? If you were to differentiate log of f, that's what will give you this. So therefore, if I integrate, I mean, that's what all of this is about. All of your integrals are built off of derivatives, okay? I actually don't want this space. I need it over here. If we were to think about what kind of log function this would have come from, it would have been log f, which is down there in the denominator, right? So it's minus, negative I should say, log of cos x plus a constant, okay? And of course, the great thing about all integration questions is you can check it by differentiating, right? And you'd go, okay, f dash, negative sign, another negative, cancels out, and then over f, it works out, you get back to 10, okay? So these are the kinds of things you'll see. All of these ones which are just, this one, okay? These ones where it's just a constant, that's a constant coefficient that gets chucked in, these are so common, they actually get given to you on your table of standard integrals, okay? Let's say the integral of cos ax with respect to x is 1 over a sine ax. And then the integral of sine ax, you get the idea, okay? But they're all very similar to each other. Like I said, variations on a theme, okay? Now, being this is trig, and you've spent a big part of your life thinking about how to manipulate different trig functions together, the next kind of variation is ones that require identities, okay? Oh, wait, let me do one more before I get to that. We will get to this in a second, but let me just give you one more reverse chain rule. Suppose I gave you this. Okay, Now, you have the advantage of me telling you, again, this is reverse chain rule. How could you go about it? Can anyone see it right immediately off the bat? Anyone? Now that's fine, that's okay. If you can't do that yet, that's a signal to you that reverse chain rule is the kind of question that you should approach by substitution, okay? Of course, eventually, like these kinds of questions, you think I don't need to do let u equal 5x. I can do that in my head. But when you can't do it yet, you should substitute. What kind of thing should I introduce for, let me rule this off, for u? What should I pick? Sine. I think that's a good choice. Okay, I'll ask you in a second why you chose that. What do I do with this now that we have chosen? You differentiate, which gives you cos. Now what? I could make dx the subject, or alternatively, I could see that, because I know where I'm going to use this, right? I can see, look, there's a cos x dx right there. So I can kind of just say this. Kind of. Okay? For the intents and purposes that we're working with, it'll work just fine. So therefore, what's this integral really equal to? What would I write? That'd be u squared du. Actually, that's it, isn't it? Right? So therefore, that's u cubed on 3 plus your constant. Sorry, this is dying. Which is just sine cubed. Okay, hold on. Let me just come back a step. Why did you choose sine and not cos? Why did you choose sine? Because it's the one that's squared, right? So in some senses, that's how you know this is the function that's important, and this is just coming along because it's the derivative of this, of the inside function.